welcome to AccuWeather's Ask the Experts. I'm Jeff Cornish. Whether you nerd out on it or just want to know more about it, we talk to some of the best minds in meteorology, space, and science to get answers on everything you've wanted to ask. So on today's show, we're going to explore some weather forecasting phrases, weather terms, things you may have heard, but you might be unsure about a few of these. And we're going to kind of focus in on some terms that you may see or hear as we go from spring into summer. So joining us as our expert today is AccuWeather Senior Meteorologist Courtney Travis, who, in addition to working as a forecaster and shift coordinator, she also leads training for our forecasters. So Courtney, thanks so much for being with us today.
Absolutely. I'm happy to be here.
Well, we're glad to have you here. And tell us a little bit about your journey and how you got to AccuWeather.
Yeah, it's been a long journey at that. I started as a kid being really interested in the weather and then studied hard, went to Penn State, and then have been here now over a decade.
All right. And where are you from?
I'm from outside of Philadelphia, so not a far cry from State College, staying in Pennsylvania, but you know, we've got some interesting weather here, that's for sure.
Absolutely. And what, when you were growing up, really drew you into the weather? Was there a place you'd like to be, or a storm, or one experience that you had?
Yeah, I don't know that it's all one experience, but certainly going down to the Jersey Shore, which was a very Philly thing to do, go down to the Jersey Shore in the summer, certainly sparked some interest in that.
Okay, that makes a lot of sense. I know the sea breeze can be fascinating.
Yes.
Seeing snow at the beach, which is rare, but it can
happens.
Yeah, I guess rare because for me, I typically find myself there only in the summer.
Right.
But it is cool to see if you happen to be there during the quote-unquote off season. Well, we want to look at some weather scenarios and things that you could help us with, some of these weather setups to explain words and phrases and what they mean. So the first one we want to begin with is a term we use especially in the spring and summer, and that is cold air damming, how cold air can get dammed somewhere. So where and when do we normally see this?
Yeah, so we're really needing two important ingredients to get this to work. You need cold air, so you can't have this happening in the tropics or someplace that's warm year-round. And then number two is that change in elevation. You kind of need that so that the cold air can kind of get stuck and not able to overcome that elevation.
Okay. I know that a lot of people often say, you know, even when you're young and in science class, warm air rises.
Yes.
So what is that all about? I guess we have to talk about density to kind of break this down a little bit.
Yeah, exactly. Cold air is more dense than warm air. So that's kind of part of the reason it can't overcome that elevation, is it kind of gets stuck and can't overcome that mountains, and then instead we have the warm air that rises above it.
Okay, and some of you who may live in a valley location, for example, not far from State College, we live in the Ridge and Valley region in Pennsylvania, and sometimes that cold air is very stubborn. We might have warm air streaming in overhead, but that cold air can really get stuck. So with the orientation of certain mountain ranges, are there areas where, at least in the U.S., we often see cold air damming?
Yeah, we often see it across parts of east of the Appalachians. You'll see it. You can get it in the Rockies. Basically, any place that you can kind of get cold air to kind of get wedged in from the east.
So what are some cities in the eastern U.S., east of the spine of the mountains, where we're especially prone to cold air damming?
Yeah, you're talking about like Harrisonburg, Virginia. You talk about Roanoke, Virginia. You get down to Asheville in North Carolina. Really common place to see that.
And sometimes we even see it as far east as maybe Charlotte.
Yeah.
Granted, it may not be as dramatic there. I know a lot of regional weather terms there sometimes refer to this as the wedge.
Yes.
So they're talking about kind of this three-dimensional view of things. And that's what we're showing here, this wedge of cold air near the ground. Now, if temperatures are especially cold or borderline chilly, what can this do with precipitation?
Yeah, the warm air kind of sitting on top of the cold air often can help create precipitation. And then you're, thinking, oh, it's going to be a rainy day. But if that cold air is cold enough, now we're talking about ice, maybe even snow in a place that you wouldn't expect it.
Okay, fascinating stuff. And this is very relevant, especially in the spring sometimes in the summer, though, too. Well, we want to delve into water spouts next.
Okay.
And these are really photogenic. But what is a water spout and where do they typically occur?
Yeah, water spouts are just swirling columns of air that are developing over the water. So they're kind of pulling the water up, which allows us to see them. And it can really occur over any type of water, but certainly across the Great Lakes, Lake Michigan and Lake Erie, or across the ocean in the Gulf of Mexico.
And we know that there are two classifications. There are fair weather water spouts and then tornadic water spouts. So what's the difference between these?
Yeah, the fair weather water spouts usually don't occur congruently with thunderstorms. Instead, they kind of just stay put. They don't move very much. But then you're talking about the ones that do form in thunderstorms, and those are the ones that typically move and then can push over land and can be tornadoes and dangerous.
Okay, and when they move over land, does their definition change, or are they still a water spout?
It moves to land spout, and again, the potential for a tornado. But they do usually dissipate quite quickly, but before that happens, certainly it's dangerous.
Okay, we've been showing some really cool footage of various ones. And they happen in Europe, they happen in the Black Sea, it could be anywhere. And the Keys, the Florida Keys, they see a lot of them down there too. Another phrase that gets thrown around in meteorology, sometimes people say we're getting a backdoor cold front. So break this down for our viewers. What is a backdoor cold front?
Yeah, so when you talk about how weather systems in North America move, usually we're talking about them moving from west to east, most storms at least. Well, when we're talking about a backdoor cold front, it kind of feels like the weather's moving the opposite direction, and instead you're seeing that cold air and new air mass move in from the northeast or the east.
In the schematic, we have a cold front that would be moving from, say, eastern Pennsylvania into West Virginia, which may feel backwards, but that is the behavior that these things take sometimes. And what kind of experience would this be like in eastern New England?
Yeah, it would definitely be cool and chilly, and again, compared to someplace on the other side of that front, it's going to be a huge difference.
Are there any smaller scale kind of microcosms that are kind of parallel to backdoor cold fronts that come to mind?
I think that the one thing that we kind of touched on a little bit is at the beach, you're talking about a sea breeze. It's a nice warm afternoon. All of a sudden the sea breeze kicks in and it gets chilly and cold. That's the wind moving that cold air over the water, over to land, making that stark difference in temperature.
All right, that makes good sense. And in some cases, this can really drop the temperature in a hurry.
Yes.
In many areas. Well, another question we wanted to ask about, and this is where it gets a little bit more tricky sometimes, a little bit of thermodynamics, the difference between relative humidity and dew point. I know a lot of people in the public, they really love a 0 to 100 scale. Relative humidity is expressed as a percentage, but sometimes meteorologists, we kind of balk at that, and we always prefer the dew point.
Yeah, so the dew point, again, meteorologists really prefer that, and there's a couple reasons. One is that the dew point temperature is really the temperature you have to cool the air to be able to see precipitation or saturation. And really the good reason to use dew point is the higher the number goes, the more humid it feels. And that's not necessarily the case with relative humidity.
Right, and most people are generally interested in how's it going to feel when I go outside. So that's why we have the AccuWeather real field temperature, and the dew point and the humidity are a big factor in that. But I think in popular discourse, people are not trying to have a heavy-duty thermodynamic conversation.
No.
They just want to know, is it going to feel really, really humid out there or not? And the tough thing about relative humidity, if you have an air temp of 4 degrees and the dew point is 4 in February, it does not feel humid, but you're at 100%.
Yeah.
So that's a tough thing. So at what point does the dew point make it feel uncomfortable?
Usually if you're in that 40s to maybe 60 range, it feels pretty comfortable. But once you start to climb through the 60s, that's where it starts to feel a little sticky, a little more humid. And then certainly in the 70s, and you get to the upper 70s, it really feels uncomfortable. But it really depends on what you're used to. Out in Arizona, in the summer, it only gets into the upper 50s. But in New Orleans or Miami along the Gulf Coast, it's in the 70s all summer. So it really depends on what you're used to.
And sometimes in the West, it's just amazing. West Texas, New Mexico, during a wildfire danger setup, we can get sub-zero dew points, a dew point of 4 below zero, but an air temp in the 80s or 90s at times.
Yeah, so it can feel really different, and that's why dew point is such a better gauge of that humidity level, because the relative humidity could fluctuate so much even throughout the day and doesn't give you a good gauge of that.
It is relative to the air temperature by definition.
Yes.
All right, good stuff there, Courtney. Thanks for helping us understand a little bit more about that. We have a viewer question that we would like to hear. And this comes from Daniel in Texas. So Daniel writes, sometimes I hear my local weather person say bow echo when it's stormy out. So what are we talking about?
Yeah, a bow echo is really just a line of thunderstorms, and the bow part is really trying to characterize what it looks like. So instead of it being a straight line of thunderstorms, which you might see with a cold front coming through, the bow echo is going to instead have this little bit of a bulge that goes forward ahead of everything else. So really what you're looking for is just that shape. It's created when you actually get a downdraft, a super strong push of wind behind the storm, pushing it forward and bulging it forward, in addition to creating some gusty winds.
And where would the winds be strongest with a bow echo?
You can really see them almost anywhere, but certainly in that central to lower part is really where you could see those strongest winds.
Okay, so that's something to keep in mind, and it makes sense. It does look like a bow there. It's a curved line as opposed to a totally linear line there that you could place a ruler on, and you wouldn't have any deviation from that. So thank you there, Courtney. And at the end of our show in Weather-Wise, we're going to show you 3 interesting things that you can see in the sky that have fun names, and we're going to talk about what they mean. But coming up next, what is an atmospheric river? How about a scud cloud or a derecho? All terms that you may have heard, but you need to understand better. And Courtney and I will help you to do that as we ask our expert, Courtney Travis, here when Ask the Experts continues. Welcome back to AccuWeather's Ask the Experts. I'm Jeff Cornish, and joining us today, we are joined by Courtney Travis as we talk about weather terms and phrases that you sometimes see and hear that may not make a whole lot of sense until you get a little more acquainted with the weather. So we're giving these more context with senior meteorologist Courtney Travis here, and she has been very helpful here through our first block. So let's just continue on into number 2. And Courtney, there are certain weather terms and phrases that start getting used more and more over time. I think the media might gravitate towards some of these.
A little bit.
Right. And one of these is atmospheric river.
Yeah.
Yeah. So what is an atmospheric river?
It's really just a narrow, long column of air in the atmosphere that gets used as kind of a transport for air and for moisture. It'll really take moisture and the water vapor from a more tropical, wet region into something that's not necessarily a wet. So we'll necessarily see that transport and in addition, we end up with a lot more precipitation in some places that might not normally see it.
And this is a really broad thing vertically within multiple levels in the atmosphere. So what parts of the United States, for example, would be more likely to see an atmospheric river?
Yeah, there could be a lot of places, but because these atmospheric rivers tend to happen over water where it can pick up that tropical moisture, we're talking about like the west coast of the U.S., even western parts of Canada can really see that long band of wind start to pull up that river and bring precipitation.
And when I was first learning about meteorology, I graduated in 2004. The term was the Pineapple Express.
Yeah.
I know that's a subset of what we now call atmospheric rivers. So how does this relate to atmospheric rivers as a whole?
It really is a type of atmospheric river, just kind of narrowing down where the location is. And then the Pineapple Express is an atmospheric river that starts out in Hawaii and then kind of transports that moisture all the way to the northwest, and you see heavier precipitation, but it's called the Pineapple Express because of the pineapples that they grow in Hawaii.
I'm on board. And you can see the scale of what we're talking about, multiple thousands of miles, maybe 2,000 or 3,000 miles, and this could be a really robust game changer here for moisture. So what's the experience like for this example, if you were sitting in Olympia, Washington?
It's going to be a wet one. It's not going to be a dry experience. So instead, you're going to feel that humidity that we talked about earlier, that moisture in the air in the West Coast, again, where sometimes it can get quite dry.
Okay, and I'm beginning to hear this in public discourse a little bit more for the eastern U.S. At times, not your typical storm setup, but it's being used to describe weather patterns in more areas, I've noticed lately.
Yeah, and sometimes the generic form and word that we'll use for an atmospheric river is tropical connection. There's tropical places all over the globe. So if you think about the East Coast, we have that tropical connection that comes from the Gulf up into the East Coast, even from the Atlantic. The difference in the East Coast is because of that west to east transport of storms, it kind of gets pointed out over the water, so you don't see that ringing out of moisture like you would on the West Coast, but it's still there. It's still a tropical connection.
Okay. Switching gears to scud cloud. Sometimes during severe weather conversations, people might say it looks like a tornado, but it's actually a scud cloud. So what are they talking about? What is a scud cloud?
Yeah, a scud cloud is really a cloud that just kind of forms at the base of the rest of the clouds. It's irregularly shaped, it's wispy in view, and again, it looks like it's sitting kind of below things, which makes sense of why it could be really easily confused. So usually a funnel cloud before a tornado starts is also sitting below like the deck of a cloud. Scud itself is actually an acronym for a type of cloud, it's stratocumulus under deck. And deck is kind of that level of the clouds that meteorologists use.
Is there one thing that's kind of like the litmus test that determines is this a funnel cloud or not?
I think that the shape and kind of what it looks like is one, that it's not going to be irregularly shaped when you're talking about a funnel cloud. It's going to be more dense, it's going to be really narrow, but instead it's going to be swirling too. A scud cloud's usually going to kind of float along instead.
And with a little bit of imagination, a lot of clouds can look scary, but
Yes.
if you don't see clear-cut rotation, then it's probably not a funnel cloud.
Yep.
It might be scud. Well, this is good stuff. We have Drew joining us from Pennsylvania. And Drew, we would love to hear your question. So what would you like to ask the experts?
Hey, Jeff. Hey, Courtney. One phrase I hear a lot on the news is derecho. I think I'm pronouncing that right. Some might confuse that with a tornado, but they're very different. Can you break that down for us?
Yeah, absolutely. That's a great question, Drew.
Thank you, Drew. It's good to hear from you.
Yeah, so when you're talking about a derecho, it's really easy to confuse them for a couple of reasons. Reason number one is they occur in stormy weather and they cause a lot of damage. So it's really easy for them to be confused together because of that. But there are some significant differences, like you said. And one is that derechos are usually much wider scale. We're talking about something that is hundreds of miles wide and causes damage paths that have to be over 400 miles long for them to even be classified as a derecho. And you're going to see strong winds, but they're straight line winds. So they're all kind of pushing the same direction.
That's pretty interesting stuff. I know that sometimes during a squall line type event, there's often a conversation. Is this a derecho or
Yes.
not? So the damage needs to be pretty consistent. There can't be big gaps without damage in between these points.
Yeah, exactly. It has to be consistent and you have to see a lot of damage, and there's criteria for that. But one is that damage width path. And like you said, no breaks.
I remember back, it was a Friday, June 29th of 2012. Some of you remember from near Chicago to D.C., just a tremendous derecho tore through a big chunk of the Midwest and into the Mid-Atlantic states with just millions without power.
Yeah, absolutely. And instead with tornadoes, they're much smaller, so they can cause a lot of damage, same amount of wind, but it's much smaller scale and fortunately not 400 miles long.
Okay, well, that's certainly a big difference there.
Yeah.
Drew, thank you so much for taking time to ask the experts and dialing in. Well, that'll wrap up our question and answer segment. I want to thank Courtney Travis for joining us. Courtney, thank you so much.
Yeah, absolutely.
When you have a question about weather, space, or science, you can write to us and send us a video question at asktheexperts@AccuWeather.com. You can also call us at 888-566-6606. Up next, in Weather-Wise, 3 interesting things. Ask the Experts returns after a quick break. When you have a question about weather, space, or science, you can write to us and send us a video question.
Absolutely.
Welcome back to AccuWeather's Ask the Experts. It is time for Weather-Wise, and in today's segment, we showcase 3 interesting things we can see in the sky. Atmospheric optics are a cool part of meteorology that involves sometimes surprising or amazing scenes resulting from the interaction between light and the atmosphere. First up, we have halos. A halo is a circle that forms around the sun or the moon. Halos are more common in the winter because a halo occurs when light refracts or bends off ice crystals inside cirrus clouds, thin clouds that are high in the sky. So halos are most often a bright white ring, but they can also have color, and they can be a harbinger of bad weather as moisture increases upstairs. Second, let's talk about sundogs and moondogs. These are bright spots you can see on either side or sometimes on both sides of the sun and the moon. Again, more apt to be seen in colder weather because they are interactions with sun and ice crystals often within thin cirrus clouds. They're called dogs because they look like either the sun or the moon is walking a dog. In other words, the spot appears to be on a leash or on one side or the other. Sundogs are seen in the day, moondogs at night. Like halos, these spots can be bright white or they can also have hues and color resembling a rainbow. Finally, the most familiar atmospheric optic is, in fact, a rainbow. Many of you may have been on board with this here at Guess that. Rainbows occur when the sunlight hits water droplets, usually near the edge of a downpour, and the light scatters through the water and is refracted or bent in different colors, revealing the full visual spectrum of light, all the colors of a rainbow. Hey, thank you so much for joining us on AccuWeather's Ask the Experts. I'm Jeff Cornish. Remember, when you have a weather question, you can email us at asktheexperts@accuweather.com or call us at 888-566-6606.